Hello, hello. Yes, living in isolation is getting to all of us. Today we have another revision of probability, and this is Venn diagrams. This will come with the tree diagrams. Venn diagrams is the second most important, maybe the most important part of probability. So let's have a look. So you'll see the notes loaded. First of all, your first page will be blank. That is because I need you to do something. Yes, wake up, Simiso, wake up. Okay, so first of all, a sample space is represented by the block. The events are represented by circles. But do not forget, I can't stress that enough. Do not forget the info or the data that does not go into any of the events has to be listed on the outside of those circles. Right, so let's have a look. We're going to color in a little bit. This is what you would have done in class. So, if I say to you the union of set A and B, union in English, another word for union means or, okay? The recognized probability symbol is a smiley face. Just think about it. If mom says to you, you can have Nikes or Adidas, you get to choose. You are happy. You are smiling about it. Right, so what does or means? When I look at a Venn diagram, I can have A or B. I am not told by my mother what I should choose. Right, the intersection of set A and B, intersection is and. And is an unhappy face. You and your sister will share that chocolate. Yeah, you're not happy about that. Now, and is where they overlap. So it's only in the middle bit. Right. The complement. We just spoke about the complement. The complement is everything but. So the complement of set A is everything. Oh, don't go into the circle. Everything but the event. Right, the complement of set A or B. So where is A or B? A or B we just saw is both circles. So outside, so leaving the or out of it, everything outside is the complement of A or B. And the complement of A and B. So where is A and B? It's in the middle. So if I highlight that, everything but that intersection will be included in my answer. Great. Quick recap of that. So, if we look at this, I just want to try and get everything. So, example 10. Right, so if we look at these two Venn diagrams, I've got event A and B in one, and there is an intersection between them. And out of the 6 numbers, there's only one number that did not fall in those events. If I look at my second Venn diagram, what's the fancy word for this? This is mutually exclusive. Okay, you can't come to my party, I will have my own. Right, so what is the probability of A? Let's have a look. What is the probability of A? So how many numbers do you find in A? So if I had to go and write down the set. So A is 2, 4, and 6. And B will be 3, 4, 5, and 6. So my number of values in my sample space. So my sample space is 1, 2, 3, 4, 5, and 6. There is 6 possible numbers. Right. So what is the possible numbers for A? 1, 2, 3 out of the 6. So that is a half. How many numbers do I have in B? There's 4 of the 6 numbers, so it's 2 over 3. Right, so here comes the funny thing. What is the probability of not getting A? So that is as good as me saying 1 minus the probability of A. So 1 minus a half is a half. What is the probability of not getting B? Is 1 minus the probability of B. So it's 2/3. So what is left for not B? That's a third. What is the probability of A or B? So A or B is inside 1, 2, 3, 4, 5 of the 6 numbers. What is the intersection? How many numbers? There's 1, 2 of those numbers. So it is a third. What is the probability of not A or B? Oh, sorry for that. What is the probability for not A or B? So what is the probability for A or B, and subtract that from 1? So A or B is 5 over 6, so what is left is 6. What is the probability of, this is the complement, so it's 1 minus A and B. Now what is the intersection? It was a third, so what is it? It's 2/3. You with me so far? Yes, no, maybe. Oh, it felt good to say that. Right, what is the probability of A but not B? So A is 2, 4, and 6, but 4 and 6 is also part of B, so I'm not allowed to include them. So it's just 1 of the 6 numbers. What is the probability of not A and B? So B is 4 over 6, but 2 of those numbers are part of A. So it's only 2 over 6, which is a third. Right, now here comes the tricky ones. Okay, I just want to zoom out. I want you to still be able to see the Venn diagram and the question. Right, so they say, what is the probability for A or not B? What are we going to do now? A and not B. Anyone, do you have an idea? A or not? I'm going to give you 2 seconds to think about that. A or not B? Yes? Okay, let's have a look. That is A, right? Not B is everything on the outside. Okay, so there's 1, 2, 3 numbers in A, and not in B is another one. So it's 4 out of the 6 numbers, so it's 2/3. Okay, now let's look at it again. What is the probability of not A? So not A is everything out there, and B. Well, B includes 4 and 6, so it is 5 out of the 6 numbers. Okay, and then finally, what is the probability for C or D? Now we move to the second one. Let's look at this one first. So the sample space is 7, 8, 9, 10, and 11. Event C is 7 and 8. Event D is 9, 10, and 11. So there's a total of 5 numbers. So C or D. Well, C or D is 5 out of 5. That is 1. And then the last one says the probability for C and D. Well, is there an intersection? No, there is not. That's 0. Great stuff. Okay. So let's have a look at drawing a Venn diagram. Okay, so there are 420 learners in a school. Okay, so the number of my sample space is 420. The number of soccer players is 190. The number of cricket players is 260. And the number of soccer and cricket is 60. So what does that tell you? That my one event will be soccer, soccer, and my second event will be cricket, and there's a overlap. Right, so we always start from the inside and work our way out. So the inside is 60. Now soccer must equal 190. So if I already have 60, it means I have 130, because 130 plus 60 is 190. Cricket is 260, so if I have 60 already, I have 200. 60 plus 200 is 260. Now here's the part that you forget. Is 200 plus 130 plus 60 equal to 420? No, it is not. It is 390, which means there are 30 learners that are not playing soccer or cricket. Okay, so the probability of soccer or cricket. Let's think about that. What is the probability of soccer and cricket? So where am I going to find this? In both events. So that is 390 of the 420. If you put that in your calculator, you will get 13 over 14. What is the probability that a learner chosen at random place? Neither. So what am I doing? I'm looking for the complement. So it is 1 minus 13 over 14. So it's 1 over 14. What is the probability that he plays only one of the two sports? Only one of the sports. So not both. So only soccer, only cricket. So it is 130 over 420 plus 200 over 420. That's 330 over 420. In your calculator, you'll see that that's 11 over 14. And then what is the probability? when a learner is chosen at random, does not play both sports. So what's that? Let's think about it. What is the probability does not play both sports? So, it's only soccer, only cricket, and no sport. That's also an option. So if I add that, 130, 200, that's 2, that's 3, 60 out of the 4, 20, and that's 12 over 14, which can be simplified to 6 over 7. Calculate if it plays both soccer and cricket. That is my intersection. That's 60 over 420, and that's 6 over 42. Can I divide by 2? Yes, that's 3 over 21. Can I divide by 3? That's a 7. Great stuff. You are doing very well. Just keep on going. As I said, the more examples you do, the easier it gets. Now the following one, I want to mark with 10 stars if I can. This is typical grade 11. Why? Because we are going to add an unknown. So let's see. The probability that a person drinks milk. So milk is my first event. The probability of the person drinking water is my second event. Now look at this. They are saying to me that he does not drink milk or water. That is not my intersection, people. That is my loners. That's the people that stands on one side. So I have milk, I have water, and I have people that don't drink milk and water. Now they're asking me, calculate the probability of drinking both milk and water. Don't be tempted to write 0,6 here and 0,3 there, because what both of those values are influenced by the intersection. Do I know anything about the intersection? No, I don't. So you can do this using a Venn diagram, or you can do it using the probability identity. So if I had the probability identity, I know that this is the equation I am looking at. I have got A or B. I don't have a 0,8. Because why? Because 0.2, it must equal 1. So that will be 0,8. Probability of A, 0,6. The probability of B is 0,3, and I don't know that. Okay, so let's see if my working with the identity, where I get 0,1, is going to give me the same answer. So what if they force me to use a Venn diagram? I don't know what the value is for milk and water. So I make it x. So milk will not be 0,6, it will be 0,6 minus x. And water won't be 0,3, it will be 0,3 minus x. Okay, so what do? I know that 0,6, that's using the identity. 0,6 minus x plus 0,3 minus x plus my people that's not normal must equal 1. So minus x plus x will give me 0. That's 0, 9. That's 1, 1 minus x equals 1. If x moves to that side, 1, 1 minus 1 gives me 0, 1. So two possible ways for me to solve this question. Either draw a Venn diagram or use the probability identity. Right, what is the probability of drinking only one of the two drinks? One of the two drinks. So it is only one of the two drinks. So if I had to quickly adjust my Venn diagram, that's 0, 6 minus 0, 1. So that's going to give me 0, 5 for milk. And if I say 0, 3 minus 0, 1, I get 0, 2. That's for water. So just for milk, or just water is 0, 5 plus 0, 2, that's 0, 7. Okay, easy stuff. You are going to practice it using this exercise. It is loaded onto the classroom maths. I have taken out the questions I don't want you to do. So based on the examples I've done with you, there's number 1, there's number 2, number 3, and number 4. Have a good day, grade 11s. Look after yourself. I definitely want to see each and every one of you back in my class and on the corridors. And we miss you, and our lives are boring, and it's very much harder raising a 7-year-old than it is having 25 of you in my class. So that's a compliment. Have a nice day. Goodbye.